Hi guys, in this video I'm gonna talk about data scaling and regularization using a real dataset. In summary, in this video I'm gonna load the Wine dataset and then I'm gonna split this dataset into train set and test set. After that, I'm gonna discuss how to scale the data. Next, I'm gonna talk about the overfitting problem and explain the solution method to solve this problem. Finally, I'm gonna show how to build a logistic regression model. First of all, let's load the dataset. The dataset I will be using is the Wine dataset, which shows the types of wine. You can find the link of this dataset in the description box below. Let's import pandas and numpy. Import pandas as pd, import numpy as np. Next, let's load the dataset with pandas. df equals pd.read csv. Let me set the name of data wine data. I don't want to get the header of columns. To do this, header equals none. Okay, dataset was loaded. Let's add the names of the columns to this dataset. I'm copying the column names I prepared before here and paste in this cell. You can find the link of the notebook I used in this video in the description box below. Okay, I assigned column names to the dataset. Let's see the first rows of the dataset. To do this, I'm gonna use heat method. Here you are. There are 3 different classes in the dataset indicated by 1, 2 and 3. We can see these classes with the unique method in NumPy. Let me set np.unique method df. I'm gonna select class label. As you can see, class label has 3 subcategories. Now let's determine the input and output variables in the dataset and convert them to NumPy array. To do this, I'm gonna use iLook method in pandas. X equals df.iLook square brackets colon comma. First column is our target variable. To create input variable, I am gonna select the columns after first columns. 1 column. To convert this variable into NumPy array, I am gonna use values. Remember, scikit-learn likes working with NumPy arrays. Now let's create output variable. I am gonna use iLook method again. Y equals df iLook colon comma 0 dot values. Okay, I assigned the inputs to x and the target variable to y and converted them to array. When performing machine learning analysis, the dataset is split into train set and test set. The model is built with the train set and the models is evaluated with the test data. Now let's split the dataset into training and testing using the train test split function. First, let's import this function from sklearn dot model selection import train test split. Let's split the dataset into train and test using this function xtrain, xtest, ytrain, ytest. Train test split. I'm gonna set input and target variable x, y. I'm gonna use test size parameter. For test size parameter, let me set 0.25. This means that 25% of the dataset will be the test and the remaining 75% will be the training set. To get same data, I'm gonna use random state. Let me set 0. To split both the training and test datasets with the same classification as the origin dataset, I'm gonna use stratify parameter. Let me set y. If you don't use this parameter, there may not be a balanced class distribution. Okay, we create our training and test sets. Let's take a look at how to scale the datasets. You can have variables in your dataset with different metrics. For example, one of your variables may take values between 0 and 10, while another variable may take values between 1 and 10,000. It's a good idea to scale the values of these variables. For example, between 0 and 1, standardize the data. Data scan is an important step in data preprocessing. Machine learning models and better with scaled data. You can use normalization and standardization techniques to scale the data. With normalization, you scale the data to a range of 0 to 1 using the on-screen formula. In this formula, we subtract each data from its minimum value and divide by the difference between its maximum and minimum value. Instead of doing this operation manually, we can use the min-max scaler class in scikit-learn. To demonstrate this, let's first import this class from sklearn dot preprocessing import min-max scaler. Let's take an example from this class. Scaler equals min-max scaler. First, let's train the parameters according to training data and transform the training data. For this, I am gonna use the fit transform method to do the fit and transform operation together. Xtrain norm equals scaler dot fit transform. Let me set xtrain. Now let's do this transform for xtest. Xtest norm equals scaler transform. Let me set xtest. Another method for scaling data is to standardize the data. With standardization, we scale the attributes so that the mean is 0 and the standard deviation is 1. Thus, all columns in the dataset are standardly distributed. We do this using the formula on the screen. Subtract the mean from each value and divide it by standard error. It is very easy to do these operations with the standard scaling class in scikit-learn. Let's show it. First, let's import this class from sklearn preprocessing import standard scaler. Let's take an example from this class. Std scaler equals standard scaler. Let's train the parameter using the training data and transform the training dataset using these parameters. X train std equals std scaler dot fit transform. Let me set xtrain. Now let's transform the dataset again using the training parameters. X test std equals std scaler dot transform. Let me set x test. Thus we have standardized the variables in the dataset. If your dataset is small and your dataset has many outliers, then you can use the robust scaler class. Now let's take a look at what is overfitting problem. If the performance of a model is good in training dataset but bad in the test set, it means that there is an overfitting problem in the model. The overfitting problem cannot be generalized to predict new data. In other words, the model predicts the training data well, but has difficulties in predicting the data it has not seen before. To solve the overfitting problem, you can collect more data, you can use regularization, you can choose a simple model with fewer parameters, you can reduce the size of the data. Now, let's look at the regularization approach to solve the overfitting problem. You can use L1 and L2 regularization methods to reduce model complexity. With these methods, large coefficients learned by the model are penalized in order to reduce the complexity of the model. You may ask the question, what is the difference between L1 and L2 regularization? L1 regularization brings more feature coefficient closer to 0 than L2. For example, if you have a large number of attributes and most of these attributes have little effect on the target variable, then you can use L1 regularization. In short, L2 regularization penalizes coefficient more than L1. You can use the penalty parameters for L1 and L2 regularization. Let's show this for the Wine dataset. Let me use a logistic regression model for this analysis. Let's import this model from sklearn.linear model import logistic regression. Let's take an example from this model and determine its parameters. LR equals logistic regression. As default, penalty is L2. To see the default values of the model's parameters, you press the tab and shift together. Our dataset don't have much attributes, so I'm gonna use L1 regularization for penalty parameter. Penalty equals L1. By default, C is 1. You can increase or decrease these values according to your analysis. To increase the regularization, you should choose the C parameter smaller. In other words, the smaller the C parameter, the more the coefficient approach 0. Let me set C equal 1. Note that when using the regularization, it is necessary to choose a different optimization algorithm. The default solver parameter is LBFGS. For solver parameter, I'm gonna use liblinear. In this analysis, since I'm gonna be performing a class versus others analysis, that is binary analysis, I'm gonna write one versus rest. For the multi-class parameter, I'm gonna use OVR. You can see default the other parameter. Okay, we create an example from the logistic regression class. Now, let's fit this model for our dataset. Let me set lr.fit. I'm gonna set first input variable x train std. After that, target variable y train. So we build our model. Now let's see the accuracy of the model on the training and test set. To see that, I'm gonna use score method. Print lr.score x train std and y train. Let me copy this comment and paste here. After that, I'm gonna change for test set, test and y test. As you can see, the accuracy of the model was 1 on both the training and test set. So our model predicts 100% correctly. We have built a perfect model. Now let's see the intercept values of the model. Intercept is a constant of the model. To show this, lr.intercept attribute. As you can see, the intercept has 3 values. Why 3 values, you might ask? 3 values were calculated because we perform one versus rest analysis. Now let's see the coefficient of the features in the dataset. To do this, let me set lr.coef underscore. Since we made 3 pairwise comparisons, we obtained coefficient in the form of 3 groups. That's it. In this video, I have talked about standardization and regularization. Thank you for watching. I hope you enjoyed. Don't forget to subscribe my channel, press the bell icon and give me a like. See you in the next video. Bye for now.